Percent yield is just looking at a comparison between what we actually make in the lab and what we should have made according to the math that we do. So if you look at the lab that we did last time, making sodium acetate, let's say, for example, you find out that you made 1.80 grams of sodium acetate. That becomes what we call your actual yield. But then let's say that you calculated that you should have made like 1.95 grams. That we call your theoretical yield. Okay, so we have actual yield, theoretical yield, and comparing those two gives us a percentage. So it's just sort of like comparing how many points you did score on a test versus how many you could have scored. You know, if you get 40 points out of 50 available, in theory, you would have gotten 50 if you gotten everything right, but your actual score was 40 points. So you got an 80% because 40 divided by 50 is 80, or is 0.8, excuse me. So you can do the same thing with your actual and theoretical. If you divide one by the other and then multiply by 100, you get a percentage. So in this case, I get 92.3%. And that's pretty good. Obviously, the closer to 100% you are, the better, just like a test. Let's look at a problem. So this isn't a percent yield problem just yet, but it's going to take us, it's going to kind of get us there. Okay. So it says if 27.5 grams of N2 reacts with excess H2, how many grams of NH3 would you expect to produce? So first of all, you need the balanced equation. So N2 reacts with H2. Just a simple synthesis reaction, pardon me, to give us NH3. And then to balance, it looks like since I have a 2 on the left, in terms of hydrogens and a 3 on the right, I'm probably going to go with going to 6, which means 3 on the left and 2 on the right, and that balances everything. Okay, so the question is asking us to go from 27.5 grams of nitrogen to grams of NH3. So it's just a grams of nitrogen to moles of nitrogen to moles of NH3 to grams of NH3 problem. So it should be pretty easy to set up. Let's go ahead and see if you can figure that one out on your own. Okay, so this gives me 33.45 grams of NH3. And I'm not going to worry about rounding because this is actually not the end of the problem. But this is how much I would expect to produce. And again, another word for what you expect is theoretical. In other words, the math tells me that this is how much I'll make. Will I actually make that much? Maybe, maybe not. Okay. So let's go on to the second part of the problem. It says if you actually produced 29.6 grams of NH3 from this reaction, what's the percent yield for the reaction? So it's just a matter of utilizing doing what we did up above, which was to divide the actual by the theoretical. So percent yield is just actual divided by theoretical. Oops, yield. Actual divided by theoretical times 100. And so in this case, my actual is going to be given to me in the problem. If we're in the lab, then you would be measuring it. But since we're not in the lab, it has to be given to you on paper in the problem. So 29.6 grams of NH3 becomes my actual. And so I'm just going to go ahead and do this down below. So I'm solving for percent yield. So my actual given to me in the problem is 29.6 grams. My theoretical is what I just calculated earlier, how much I should have made, 33.45. So just like taking a test, we don't always get exactly what we should have gotten or could have gotten. And so I'm just going to do the math. So see what you get there. Okay, so I got 88.49%. And if I look back at all of the measurements or measured values, 29.6 and going up above 27.5, those all have 3 sig figs. So I'm just going to go ahead and round this to 88.5%. Okay, let's do one more problem. So this one is a little different because instead of breaking it up into 2 parts like we just did, so in the previous problem, I first specifically asked you how much would you expect to produce. And then I said, okay, if you actually produce this much, what's your percent yield? Most percent yield problems don't really break it down that much for you. So you just kind of have to know what to do. So let's practice that. So if it says, if magnesium carbonate reacts with 7.92 grams of sodium nitrate to produce 6.15 grams of magnesium nitrate, what is the percent yield? So we just have to sort of break this down and think about what the numbers are that are given and how we're going to use them. We do, of course, need a balanced equation, so let's do that first. Magnesium carbonate is reacting with sodium nitrate. Double replacement, right? So what products would you get there? Alright, so magnesium nitrate, oops, and I made a mistake. This is actually sodium carbonate, right? Na2CO3. And so I'm going to put a 2 in front of sodium nitrate, and that's going to balance both sodium and nitrate, and we have a balanced equation. Okay. And normally with double replacement, we would look at the solubility rules and figure out which one is soluble, which one's aqueous. But we don't have to worry about in stoichiometry problems with it. We don't have to worry about there being a no reaction. I'm not going to give you a problem that's a no reaction. So, okay. So what is this problem asking? The first thing we have to do is maybe highlight or underline what's been given to us in the problem and recognize what it is. Okay, so we have this 6.15 grams of magnesium nitrate. So it's telling you that you made that. It's not telling you that you had that available. It's telling you that's how much you actually made. So this is my actual yield. This is the number that would have been taken from a lab measurement if we had actually done this lab. Okay, so that's your actual yield. The problem is the 7.92 grams of sodium nitrate, the other number given, is not the theoretical yield. If it were, we would just do 6.15 divided by 7.92 times 100 and we'd have our answer. But they're not even measuring the same thing. Like one is measuring, sodium nitrate and the other one is measuring magnesium nitrate. So the 7.92 grams is not your theoretical yield. You have to calculate your theoretical yield. But we're going to do that. We're going to calculate our theoretical yield of magnesium nitrate from 7.92 grams of sodium nitrate. So in other words, we need to know how much magnesium nitrate I'll say question mark grams under magnesium nitrate. We need to know how many grams of that we should have made so that we can compare it to the 6.15 grams that we did make. Okay? And the number that we're going to use to get there is the 7.92 grams of the sodium nitrate. We're not given any information about the magnesium carbonate. We're actually told that we have, it just says if magnesium carbonate reacts with so many grams of sodium nitrate. So the magnesium carbonate doesn't really matter in this problem. Okay, we're assuming we have enough of it. So what I want you to do right now is find the theoretical yield of magnesium nitrate. So find grams of magnesium nitrate from grams of sodium nitrate. Okay, so there you can see my gram to gram conversion from 7.92 grams of NaNO3, which was given to me in the problem, to 6.91 grams of magnesium nitrate. This is my theoretical yield. Okay, so that means if all goes well, that's how much I should make in the lab if I'm doing this experiment. But if you look up above, our actual yield given to us in the problem is not quite that big. It's 6.15. So the last step is going to be to take the actual 6.15 grams and divide it by the theoretical that I just calculated, 6.91 grams. And of course multiply by 100, and this is going to give me my percent yield, which is what the question was asking me for. So go ahead and do that. Okay, so this gives me 89.0% yield. So not quite as good as the previous one, but there it is. So that's how you do a percent yield problem, starting with the amount of reactant, using your actual yield to get your percent yield.